What's up, everyone? Eli here, and today I'm talking to my good friend Nico. Grew up in the same town, so it's always good to see you again, Nico. How you been?
I'm doing pretty good. It's been chilling.
Dude, that's really good to hear. Have a good summer?
Yep, it went pretty good. Hurt my elbow for a bit, but it healed up right quick.
Dude, no way. I messed up my shoulder recently.
We're both having arm
I
problems.
I'm starting to give up on letting things heal, and I just keep going back to the gym and just continuously mauling it until it behaves. We'll see how that goes in the future. I'll let everyone know. Yeah. So you're on your last year, right?
No, I think I have one more because I screwed up my first year. I did not take enough classes in it.
Oh, really?
So, yeah, well, enough important classes.
Oh, okay.
Because I had screwed up the math placement, so they put me way too low in math, even though I already knew the stuff. I didn't pay attention in the math exam, honestly.
What math was it?
They put me in trigonometry.
Oh, okay.
Yeah, and I took pre-calc in high school, so they put me down to trigonometry. So I wasted 2 semesters grinding back up.
Yeah.
So,
Damn.
at least I'm done with math now.
Are you really done with math? Because you're doing an engineering degree, right? What is
Yeah.
your degree specifically?
Civil engineering.
Civil engineering.
Yeah, so I finished my last math class this past summer, differential equations. I think that's my last one. It's the last one I have on the short-term horizon.
What was your favorite branch of math?
I'd say calculus.
Yeah?
Because linear algebra is it's a completely different paradigm to everything you learn, and it's all about lines and the various things lines can become.
So it's like the first dimension, kind of. Because the first dimension's a line, and the second dimension's like a plane.
Yeah,
Like a flat
but it's
piece of paper.
In linear algebra, we just blow past 3D shapes and go into 7-dimensional lines.
Oh, what?
And I'm
What?
like, oh, okay.
What is it? What is a 3-dimensional line?
A cube.
That's a line?
Well, 0 dimensions is a point, 1
Right.
dimension is a line, 2 is a plane, 3 is a cube, 4 is a tesseract. And then we don't know what's in the 5th dimension because it's impossible for our brains to visualize it.
How does the tesseract work?
It's you ever seen those animations of the cube in a cube?
Yeah, I've seen
and all
them,
the corners are connected, and it's shifting in and out of itself.
That's in the Avengers movie. They have the Tesseract, and it's like the cube that moves in and out.
Yeah.
And I've looked at pictures and tried to understand what is happening in them. And
True.
But I don't, bro.
Yeah,
to be honest,
few people even understand them because it's in multiple dimensions. It's in a dimension we don't even have, so how can we see it? Because we can only see things in 3 dimensions.
dude,
And then most people read about it on a computer screen, which is 2 dimensions.
if my brains are eggs, the 4th dimension is a beater, bro. I have no idea how to even think about it.
I really scrambled.
I was talking, so I was trying to figure out, and this is as someone who knows almost nothing about the subject, so I trust everything I say, and I know I have a lot of authority over talking about this. With mathematics, and almost all the branches that I know about, they use values that operate on planes essentially. So when you describe the 3rd dimension, you describe it going up, down, side to side, but you basically have 2 planes that you smash on top of each other. But it's all through planes. So you take the game like Paper Mario, right?
Yeah.
And you move on a side-scrolling screen.
And then you turn around the corner.
You turn and you see it's like a 3-dimensional world, but you can never actually
Yeah, you can't move in
maneuver
3
it.
dimensions. You can only switch which 2 dimensions you're in.
Yeah, but in that way you're able to navigate the whole world,
Yeah.
but you're never navigating it on a 3-dimensional level.
Yeah.
So I was wondering if mathematics kind of gives us a perception of the world on the same principle, because there's no real up or down or left or right. If the universe is infinite, it doesn't matter.
Yeah.
Just on
whatever direction you're
exactly.
facing.
And you have forces that pull things towards them, but it's not Like it's not up down like side to side. That's like that's taking two-dimensional things and giving them directions. Like, oh, you're going up from this dimension, this plane, and left from this plane.
Yeah.
So but like, does that make sense? Like, that's kind of how it works.
I guess sorta, because it's like we can do like 4-dimensional, 5-dimensional math, but we simplify it all down into just a grid of numbers.
Right.
And so, I mean, this is just linear algebra. I don't know what the higher level stuff does because I did not go into that. I passed linear algebra and I said goodbye to linear algebraic math.
Yeah, never to see again. Did not look back.
I went straight back to the calculus path and took differential equations and regretted it because diffie-q is tough.
All right. How would you describe the fourth dimension though? Just to like,
I'd say it's
just
like,
to give some visualization.
If you take a point and stretch it out, you get a line. Mm-hmm. And if you take a line and stretch it out, like perpendicular to it, you get a square. And if you take that square and stretch it upwards, you get a cube. But then we can't visualize how you would stretch a cube to get, like you would stretch it in every direction.
Yeah.
And also a direction you can't see.
Oh, really?
Because
I never thought about, because you go up.
Yeah.
You like stack.
Yeah, because you go up from the square and then you go up from the up. You can't go up again, so you go clockwise or whatever, you know? You go in some weird dimension that we don't even think about because, you know, it never comes up.
Do you think it's time? I've heard like people say that like time is the fourth dimension.
I feel like we use that colloquially, like it's not a dimension, but it is a thing that we exist in a world made of, it's like different definitions of the word dimension, you know?
Yeah.
Where it's like dimension can mean like a measurement, or it can mean how big something is, or how big you measure it to be. Time is just like a thing that's always passing, and so we use that to measure how much things have passed, you know?
Yeah.
And so we call it a dimension. I don't know. I'm not an astrophysicist. I think they would get mad if they heard me talking about that because, like, apparently black holes do weird stuff to time. I don't know.
Hey, we're getting there.
We'll figure it out one day. Who knows?
All right. So you're doing this nuclear like work because our campus has a nuclear reactor on it.
Yep. And it does a reactor training or reactor operator training program every year. So 2 semesters, and you come in and you learn how to work the reactor, and then once you're done in August, they have a big exam. And by big exam, I mean they slotted 4 hours for the first part and another 4 hours for the individual part. Everyone took the first part together in a very quiet and very stressed out room. And then the individual part was much chiller.
Dude, I would be so stressed out if I took the nuclear reactor exam.
Yeah.
That would be not a fun night before.
It was not, I can assure you.
What kind of work do you do?
We run, like, we operate the reactor is like the obvious answer, but it's also incredibly vague. Like, we make sure it stays within the power levels we want, and then we put samples in it, because there's all sorts of stuff you can do with a nuclear reactor, because it's the only way to make things radioactive. Like, if I have a radioactive object, and I put it near something, it's not going to make the other thing radioactive unless parts of the first object are falling off onto it. So if I have a pile of radioactive dust, I can just spread... Ooh, hit my mic. I can just spread it out and, you know, effectively make things radioactive.
You should like bring it closer to you.
Ah, I see. But, you know, if I just put a brick of radioactive metal next to something, it's not going to make it radioactive, but a reactor can. So if you put a brick into a reactor and pull it out, the brick itself will become radioactive. And you can do some weird stuff with that.
What kind of like things can you do with a radioactive brick?
Well, I feel like the most common one is you can test radiation detectors, because to detect radiation, you need a detector because eyes can't see it, ears can't hear it.
That's facts.
But it's also weirdly easy to detect. It's just humans aren't adapted to detect it in any way.
Is it like it's not waves? It's the particles flying around.
Yeah. Some of the like gamma rays they have weird wave particle duality, but like alpha particles, that's just a helium atom that's very angry at everything.
I'm dead.
And it's really easy to detect them because for it to be radiation, it has to be emitting a bunch of energy.
Okay.
So you just follow where the energy is and you find the radiation.
Do you think there's animals that can sense that kind of thing? Because they say that a lot of birds can sense magnetic fields.
Oh.
So, like, do you think there's animals that can sense kind of radioactivity? Since it does put off a lot of energy. It does put off a lot of like signal.
True.
In that way.
And aren't there like sharks that like hammerheads? They have those weird organs in their face
Yeah.
to detect electricity. I feel like they might, but I don't know. Like we'd have to test that, and I feel like no one's gonna be willing to test putting a pigeon in a room with a brick of cobalt 60 and see what happens.
Nico, maybe it's time to start.
I see. I'll be the change I want to see.
You gotta
in the world.
head this project, Nico. Win the Nobel Prize. Let's go. It wouldn't even be the Nobel Prize.
Make a bird-based radiation detector, like those bird homing missiles from World War One. The bird device.
Oh, we should definitely not do that.
Nah.
But yeah, that's cool. So what makes you interested in that kind of work? Was it just like a good opportunity, or was that something that you wanted to get into?
Well, I saw that the campus had one before I came here, and I was like, oh, that's an interesting opportunity. Maybe I'll look into it later. And then I realized that they do just have an open training program that anyone can join. Like, it doesn't cost money. It's just a time investment. And they were like, well, if you join our program, at the end of the program, you'll get a license and be allowed to operate a reactor in any state as long as, the people who own that reactor let you.
By the way, I don't think it's normal for a school to have a nuclear reactor, but
There's only like 20 schools with them, so it's very rare.
A very special opportunity.
True.
If you all go to a school with a nuclear reactor, you got to think about that.
Yeah.
Do you want to start your career there? Because you have the fucking chance right there.
True, you could. Plus, we've got a couple of national labs pretty close by, and both of those have reactors at them that I could, theoretically go work at afterwards, or I could stay at this one, or I could go find a power plant somewhere to work at.
Yeah. That's really cool. So, I got this question. What is college to you? Doing this reactor work, doing all these mathematics. Once you graduate, like before you even came here, just what is the overall value of college? Like what place does it have in your life? Not even just now, just in general, as an institution.
Yeah, I'd say before I came, I thought of it more as just like a thing you do, like high school. Like that's just a thing you do, and you go to it, and you have to do it, and then you leave at the end, and you have a piece of paper that said you did it, and that's how you participate in society. But now I see a lot more as like a mixture of a big opportunity and a place. I'm trying to figure out a better way to phrase that, but it's a place that you can do things at, Mm-hmm. If high school was a thing you do because you got to do that, college is a place with lots of things which you can do if you want to get the benefits of doing them. And there's a bunch of opportunities to, for me going through the civil engineering path, getting a degree, that's the opportunity I chose. And then also the nuclear reactor thing. It's a place with a lot of things to do, So you're saying there's opportunities even outside of the degree, there's opportunities for having the job or there's a lot you can do in college. Meeting people. Yeah, it's a big investment to get in, but then once you're in, there's lots of stuff you can do that you can follow degree path, meet lots of people, do like a work network or a employment networking, do extracurriculars like this to get, certifications and whatnot that might be useful in the future,
Yeah. Do you think that there's more opportunities here for like kind of, so, I mean, obviously there's like a wider range of networking you can do in college, but like, do you think that there's more networking in college, even besides the variation, than like being in a job? And I'm sure it depends on the job, but just like in general, like going forward, do you think when you go to your next job, do you think you're going to have more networking than you have here?
I feel like the networking floor is higher, but the ceiling is lower. Because when you're in a job, you're definitely going to make some connections.
Yeah.
But when you're at college, you have the opportunity to make a lot of connections.
But
there's no guarantee you'll make any if you're just bad.
So you think the ceiling in college is higher?
Yeah, the ceiling in college is higher, but the floor is lower.
Okay, that makes sense.
If you don't do anything, you're not going to make any, connections. But if you go out and you're proactive, you can make way more.
Yeah.
But then, in a job, to do a job, you need to make a couple connections at least. And you'll probably make a decent few just doing your job with your coworkers.
I'm sure like the professors at colleges and like people that get their doctorates here and spend a lot of time, they must make like a lot of connections. Yeah. I don't know that for sure, but
I mean, I would assume they'd have to know a lot of people given how many people go through here so often.
Yeah. Cool, man. All right. So what, another question. What do you think hasn't been explored enough?
Oh, just in general?
In general. Like on a worldwide scale, what have we not gone into enough? What has a lot of potential for humanity that we just haven't spent a lot of time on?
Well, I want to give the biased answer, which would be nuclear energy.
Yeah, okay. I'm with it. Why?
We did do a lot of that back in the 60s, but then, the Cold War wrapped up and we just sort of gave up because, don't need nukes very much.
I've always thought of it like airplanes. Like when we first were making airplanes, people were like scared for sure to like be on an airplane or like to fly on them. But as we made more and like, but they had good reason. Like in the beginning,
you're telling me this wooden bird will fly?
Right? Exactly. And then after a long time, like I wouldn't say I would have flown on any plane before the 50s. I don't really know that much about planes, but I feel like that's a good time. Like I don't like you're not showing me a plane from the 30s and like having me get on that. But I think like everyone's scared at first, and then once they get the technology, and now being in an airplane is safer than being in a car.
Yeah, airplanes are way safer than driving.
And I've always thought of nuclear power as a similar story. Like in the beginning, yeah, it's more dangerous, but the fact that it's more dangerous means that there's more effort that goes into it to make it safer.
True.
Like these coal power plants, they're not as dangerous, but like we don't put as much effort into them. They have a lot of byproducts. They put a lot of CO2, obviously, but other problematic things come from coal plants.
They actually emit quite a bit of radiation because naturally occurring uranium shows up in coal, and when they burn it, it just gets let out with all the soot and smoke.
That's crazy.
Yeah.
And it just goes like into the air?
It just goes into the air.
Yeah, and then falls on rivers.
Ironically, a coal plant is usually more radioactive than a nuclear power plant.
But for the same reason that you're more likely to get in a car crash than die in a plane. Even though a plane is more dangerous.
We made them good enough and then we stopped caring.
Yeah.
Even though the standards have risen.
Yeah.
They were good enough for the 50s. Maybe they're good enough now. Turns out they aren't.
But I don't know. There are problems with power plants. I mean, like the disasters that come from them are absolutely horrific. Japan just said that they're going to release all the water from
Fukushima
into the water, and that's a nightmare. That happened. When did that happen? That was like 10 years ago. 2011. Yeah, so about 12 years ago. And so we're still seeing the repercussions from that, and that's really bad. So like I see both sides, but why What do you think nuclear power has to offer? Like in the future, we go full nuclear power. Where do you see the world?
I think. Well, obviously, I have to be on the hopium that maybe this time, maybe this time, if fusion is only 10 years away, it'll be different this time. It was 10 years away in the 50s. Okay. Yeah, maybe this time, all that superconductor thing. I read apparently like the original sample had some impurities.
Oh, they're still working on it. Yeah, they're still
don't
trying to
even-
figure it
They're
out.
trying to figure out if they even made one, and they're arguing that it's like actually half of the coating of the sample was a superconductor.
Yeah,
Like, well,
they're holding on to it, man.
mass produce.
What happens? You want to explain fusion?
Yeah, so fusion is the opposite of fission. Fission, you cut something in half, in this case uranium, and the two halves of it go flying away very quickly. And when you're an atom, speed and heat are the same thing. So very fast bits of atoms are very hot bits of atoms, and we just use that to boil water and make steam power. It's the same as every form of power generation has been some form of steam power since like the 1860s. But then fusion is the opposite of that. Instead of taking a big atom and splitting it in half, you take two small atoms and force them together. The issue is that that's really hard to do because that happens naturally in the center of the sun because it's really hot and high pressure, and so all the atoms are being forced together and they just make a big soup and they get forced together and they fuse. And trying to make something like that on Earth is really hard.
Is it just because like they're just flying in every direction so fast that enough of them like fly into the center and fuse with each other?
Well, it's that and the gravity, because the gravity of the sun affects the whole thing. Like,
Right.
the gravity of the Earth will pull a piece of the Earth back to it. The gravity of the sun will pull a chunk of molten whatever back into the core. And so all the dense, heavy stuff in the middle fuses together. And then, that makes a bunch of energy and makes the sun glow.
Yeah.
But doing that on Earth is hard because we can't just pile gas together until it does that under its own weight.
Didn't they do it in China? They made like a temporary sun in China.
Yeah, but we have to force it to come together. Like, the sun does it naturally with gravity,
Right,
which is...
okay.
Gravity is pretty much free. But doing it on Earth with less than a sun's worth of gas is very hard because you have to force it all together, and then you need to do that in a container that can hold all that gas at that high of a pressure and without melting when it starts fusing.
It's just a like, continuous reaction.
Yeah, and they figured out that, like, that's just not possible. So that's why all the fusion reactors that people have been talking about have all had, like, magnets in them. The idea is, instead of just using normal, like, helium, you mix it with some metallic thing that makes it magnetic. And then you use the magnets to force it away from the walls so it doesn't melt the container. And that's part of the safety feature on fusion reactors, actually, is because even if everything goes wrong, the entire thing shuts down, or all safety systems shut down, the gas will rapidly expand, fill up the whole reactor, melt the interior walls, and then cool down. Because as long as the reactor is big enough, it will just stop before it melts through it. And
Okay.
even if it's too small, it'll make a little jet of fire coming out of it, and then it'll cool down. Because you need power to keep making it fuse,
Right.
The issue is just, getting that power into it to make it fuse in the first place, because we don't have very good ways of moving that much power in that small of a space.
So what was the China project? Do you know anything about it? I just read an article that said
Is
that
that the one where they used
they made it into a
lasers?
sun. I don't know, man. I remember that I read something that said they made one for like 0.12 seconds or something.
Yeah, I know the two main ways are... Because we always use magnets to confine it, to keep it from burning the outside. But then the two ways of making it fuse are using magnets to force it together and fuse, or using lasers to superheat it until it fuses. And I think most American projects are going the laser way, and most European
Okay.
projects are going the magnet way. So
That's
I don't know
interesting.
what China is doing. But there have been some recent breakthroughs in laser technology, so maybe that's what they're doing, and they're taking advantage of that and figuring out how to. Because the issue now is the lasers are just too inefficient. We can pump 100 gigajoules into the lasers. It'll turn that into 30 gigajoules of laser power, and we get 60 back out. We're still losing energy, but that's because the laser is just really inefficient.
Oh, but then once we get more efficient lasers, we have the ability to create energy. We just
Yeah.
need to like have a
The
laser that
reactor is
doesn't.
net positive. It's the laser that's cutting all the power out, at least from what the old American studies were.
That's wild.
Yeah.
Okay. I have hope. I don't know. That sounds promising,
I'm
man.
on
I
that
mean, like
hopium. I'm still on it.
we have a long ways to go with lasers for sure. That's kind of
But yeah, honestly,
that's like the wheel.
back to the original thing about like how would that change the world? Once
Yeah,
we
man.
have like just as much power as we can wave a stick at, a lot of problems become much easier. Like water shortages, one of the major issues with fixing water shortages is that desalination plants need so much energy to crack water apart and get the salt out of it. And fusion reactors would theoretically run on, light noble gases like helium or hydrogen, and thus would be able to, rip the water apart much easier with how much energy they're putting out. And that would be able to produce a significant amount of water for places that don't have very much, like, deserts.
It turns it into steam. or
Yeah,
like
I don't know exactly how it works, but I know it heats up the water, so it like steams off, and then they distill it back into normal water.
Okay,
And
yeah.
the salt is left behind in the first tank. But then, they need to clean it out, so it's more complicated, and there's like downtime. But, there
But I
are
see what
there
you're
are
saying.
desalination plants out there working. I don't know how they work though.
Yeah.
I presume they distill the water somehow to get the salt out of it. Otherwise, they aren't really desalination, are they?
I would not think so. How does fusion give us more power?
So it has to do with this thing called the binding energy, because we learned a bit of atomic physics during the reactor course. But when two atoms come together, or when two nucleons, which is what protons and neutrons are called, come together to form an atom, a little bit of mass gets destroyed. So if one proton and one neutron both weigh one atomic unit, and you
Yeah.
put them together, the resulting atom will weigh 1.9 atomic units instead of 2.
Okay.
And that energy is, or that mass that is lost is called mass defect, and it basically gets turned into the energy that holds the two atoms together. And fission works by turning that mass, or that energy, basically releasing all that energy. You crack them apart, all the binding energy gets let out, and they go flying. But
And fusion,
yeah, fusion is coming at it from the opposite angle.
it just breaks them apart and they fly away, and
Well,
then
fusion, you put them together.
Sorry, fusion. You put them together. Okay.
Yeah. And when you do that with lighter elements, I believe that's how it works. When you do it with lighter elements, they basically release a bunch of energy when they fuse, because not all of the binding energy stays within the atom.
Right.
Some of it leaks out.
And you're getting the leakage,
Yeah, you're getting the leakage. And
and that creates more energy than fusion or than fission.
I mean,
Or is it just like another
it's
way
just
of
a
doing
different
it?
way of getting the energy out.
Yeah.
Because fission, you crack it apart to get the energy out, and the binding energy just turns into heat. It turns into speed, and the bits of atoms go flying. Fusion, you end up just like pulling the heat leakage out, because the resulting atoms are faster because they fused and they have all that binding energy. But yeah, I'm not a physicist. I'm an engineer. I don't know how the atomic physics works of it. I just know.
Come on, man. You work at the plant. The expert here.
I know you split a big atom apart, you get energy out. You put two small atoms together, you also get energy out. I think it's like if it's bigger than iron, you can get energy out by cutting it, and if it's smaller than iron, you can get it out by fusing them. But the closer you get to iron, the less you'll get out.
Yeah.
Because iron is the most stable element, I think. I'm not certain, but I'm pretty sure it's the most stable.
Can you apply fission or fusion to like anything else? Like,
You can fuse anything with enough energy.
and like, do most things have that property where they like release energy? Like, I'd have no frame of reference for what else can fuse like that, because when the atoms fuse, they literally like turn into an atom.
Yeah, you take two little atoms, you put them together, you get one big atom.
But if you have two cars that like fly into each other,
You don't always get a bigger car out.
yeah, you don't exactly get it. You don't get
a semi-truck out, yeah.
You don't get a Suburban from two Corollas. But
Yeah. I mean, that's
So
how
it's-
they make the new elements, at the bottom of the periodic table.
oh really?
Yeah.
They just yeah.
They
I mean,
just-
I guess I don't know how else
They
to
just
do it.
forcibly make an atom bigger and bigger until it stops, or until it decays rapidly, and they're like, oh, that decayed slightly differently. New element.
What? That's crazy.
Yeah, it's the fun things at the bottom of the periodic table that all used to be named like UU something, UU something, UU something, and now they have real names, but I don't remember what they are.
Oh, I haven't even seen them.
Yeah, apparently
That's
they
crazy.
renamed them at some point. I still remember the oobs.
Yeah, I remember those
Oobs
too.
and ooh and uns and ums.
I would just completely ignore it because it made it so complicated. Like you're just trying to learn the actual elements, and then there's
And then there's a bunch
There's
of weird man-made ones
actual,
at the bottom.
which are actual elements, I guess, because they're there. But
They're
yeah.
real elements. They have chemical properties. It's just they're so unstable you never see them.
Are there elements like is there a possibility that there's elements we haven't found?
Yeah. So there's this phenomenon in nuclear physics called the island of stability, where basically if you plot the number of protons in an element against how heavy that atom is, you get this diagonal bar with a slight bend to it that shows all the stable it's called the chart of the nuclides, but it shows this bar of all the possible all the elements and all the possible isotopes of them.
Okay.
Because normally the bar is just straight diagonal because, as you add, you would assume as you add protons, you just, the weight goes up when you add another proton,
And it goes down when you take them away.
Yeah, so you would assume it's just a diagonal. But as you add protons, there's this weird ratio that you need to keep of protons to neutrons.
Yeah.
And that slowly drifts over the course of it. So it's more of a bent, like crescent almost shape. Like it has a little bend towards the end where the elements start having lots of neutrons on them. So you get weird elements that, they have like 90 protons, but they'll have like 100 neutrons, which is kind of a lot, because hydrogen is 1 proton, helium is 2 protons and 2 neutrons, so it's an equal amount.
Yeah.
And then towards the end, the neutrons start creeping up. And the idea is that there's this weird theory that like maybe if we keep adding protons to elements, we'll eventually reach another island of stability of so-called super heavy elements. And the whole idea is like, oh, well, they're going to be super dense, so we can use them for like incredibly strong metals if they happen to be a metal, wherever they land on the periodic table.
Right.
But the problem is that, as far as we can tell, it's just all hyper radioactive things
Oh, yeah,
that
it'll-
disintegrate
that's like
seconds after you make them.
Milliseconds of
Yeah.
half-lives.
Like the last 4 they've discovered last like a minute at longest before disintegrating into lead.
But they think they'll find like an element that will last.
Well,
That's like
some
essentially
people
like
think that there
they'll find,
are
like-
some out there.
like a super hydrogen
Yeah, like
super
like
helium.
something in like the iron category of the periodic table that's like 200 protons, and when you make it, it's like 4 times as dense as iron and stronger. But then it would probably just be super radioactive and decay instantly. We don't know.
Yeah. I mean, I assume it would be because like the more atoms you have in the nucleus,
The less stable it seems to get.
the more the energy is dispersed. I guess. I don't know.
Yeah,
I
there's a
don't
whole
know
bunch
enough about
of
this to talk about
weird
this.
quantum physics. Whole bunch of weird stuff that I don't understand. I just know as elements get bigger, they seem to get less stable.
Are elements like could there be elements that are fourth dimensional? Because you don't exactly have elements in the second dimension, do you? Do we? I don't know.
I don't really know what you mean,
I don't know what
friendo.
I mean either. No, I mean like do elements make up all of the dimensions?
I feel like, well, we don't actually, like, atoms are weird because they're made up of a bunch of seemingly massless, infinitesimally small particles, you
Right.
know? So maybe they would apply in other dimensions, maybe they would not. It's one of those things that we can't prove or disprove or even really think about
That's crazy.
because we can't think in more than 3 dimensions very well. So it's like we can barely do quantum physics in 3 dimensions.
That's
We
true.
aren't gonna try it in 4, I don't think.
Do you think it's a simulation, bro?
I don't know. The Planck length seems a little bit like a reality pixel, so maybe.
What is the Planck length?
It's the smallest distinct length that anything ever can move. Basically, because of weird quantum mechanic things, nothing can ever move a distance shorter than a Planck length. It's like how if you
What?
have a pixel art screen, like a pixel art animation,
Yeah.
nothing can ever move half a pixel. They always have to move 1 pixel, you know? So the Planck
Oh,
length
okay.
is the smallest distance that anything can move. And as far as we can tell, it's entirely natural and just a consequence of how the universe works. But also, a pixel art creature would also say that, you know?
Yeah, I guess. That's twisting me.
Yeah, it's a weird thing. It's probably just coincidence that, like, it's
How do
a
you
thing.
how do you measure that? How do you figure that out?
They did a lot of math. Math I can't even imagine.
They
But
just took every single like thing they could find and was like, all right,
how far can we move it?
but like how short can we move it, right? Because
Oh,
it's like
yeah.
the shortest distance it
The
can move.
opposite.
They have
Yeah,
an apple sitting on the counter. They're like it's just sitting still, like yo.
it's something to do with like 'cause
thing's still moving.
when you put energy into a particle, it moves, and then how little, like the smallest amount of energy you can put into a particle at any given moment. And it's like they use the smallest particles possible to transfer the energy, and it's some weird simulation like that.
Well, like they found out that atoms behave as waves, right? Or electrons.
Certain subatomic particles.
Subatomic
like
particles.
Photons, electrons,
They
probably
were
some others that I don't remember.
they were a wave and a
Wave particle duality.
and a particle at the same time.
Yeah, because if you apply a test that should only work if they're a particle, it'll come back positive. And if you apply a test that should only work if they're a wave, it will also come back positive. And so they're like, how does this work? And I think the general idea is like there's some sort of weird entangled energy state where they do the same thing as waves while being particles or something. It's like they aren't an actual physical thing as we think of. They're just like a wave, or they're a piece of energy condensed into a spot, you know?
Right.
And then energy is waves, so they can act like a wave, but then they're condensed into a thing, so they're a particle, so they can act like particles.
So since it's a
I'm
wave,
probably butchering quantum physics. If you're listening to this, Ian, I'm so sorry.
if it acts like a wave, it would move, right?
Yeah.
At all times. So does that explain the Planck distance?
I don't really know.
I don't know.
I feel like they were using some weird measurement that probably applies to both waves and particles, but I don't know what that would be or how it would work.
Dude, it's so crazy, but it's fascinating. It's
High
like
level physics is weird.
it's.
I'm glad I stopped at medium level.
we we we've only known about these things for like the last
Like 30 years, I think.
30 years. I mean,
Maybe 40.
well,
I think it was in like the 80s. You know, here's an anecdote from my father. So, my father grew up in like 70s, 80s, and he was very much a tech kid. Like he once there used to be these whistles they'd put in Captain Crunch boxes, and the whistles coincidentally played the exact same frequency that payphones used to use to transmit that that you had paid and that you could make a call now. And so with a tiny bit of modification, you could put the whistle up to a payphone, blow through it, and it would tell the payphone that you had paid, and you could make a call for free.
what?
It was weird, and they fixed it within a couple years, but it was a thing that worked for a short time.
That's
Yeah.
Those must have been some lucky people that figured that out.
Whoever was going around it, I think there was some weird thing you had to do to the whistle to make it work, but it was easy enough that, you know, with the knowledge and a bit of skill, you could make it work.
Yeah, like did you like put a piece on it or something? Or?
Yeah, you had to like attach something to it, and I think you had to use like a fan to blow through it or something. I'm not sure.
Could you imagine everyone's like paying for payphones, and then you're this one dude with this whistle that you like go and you just like blow his whistles?
Whoever figured that out was either an absolute lunatic who was just blowing whistles into payphones, or they were some mathematician computer genius who was like, I recognize that frequency. It is the exact tone payphones use.
Dude, some insanity on either side. I don't know.
Yeah. But back then, a lot of, you know, internet networks, you know, computer networks were just sort of starting to take off. They weren't that common in civilian sectors yet, which meant that a lot of sectors did not really care about security.
Yeah.
Because a lot of it was done over the phone lines. And it was like, well, we'll just get another phone number for our bank, and we'll hook up our modem to that phone number. And the only people who are ever going to call that phone number, and the only people who are ever going to know that phone number exists, are us and the people we tell about it. So we don't need to put a password on it.
Right.
So we can hook up our computers to it, and people can and employees or other banks can access it remotely. And my father discovered that a lot of these didn't have passwords because they didn't think they needed them.
It was just the phone number.
Yeah, the password was the phone number, and they never put them in, you know, the phone books because the bank already had a phone number. You wouldn't put another one on there.
Wow.
And so he discovered that a local news printer had done a similar thing, because he had set up this diabolical machine which would, over the course of the night at his parents' house, he would attach it to the phone through the modem, and for the entire night it would call random numbers, wait 30 seconds, and then hang up.
What?
And if it heard computer speech, on the other hand, it would mark the number and print it.
What? When was this? The 80s?
Like 80s, I think. Like late 70s, maybe.
That's like some Ferris Bueller type
Yeah.
technology. That's crazy.
His parents were not happy when they found out, because it was taking up the phone line for the entire night.
What?
So if anyone tried to call, they would just hear a screeching modem the entire night.
No way.
But he did get to use it for a while, and he found out that like a local news article publisher, whatever those are called these days or back then, had one of those modem things set up on an unlisted number. And he accessed it and found that it was some remote service that you could use to submit papers to the like general news network that all the journalists use behind the scenes to submit their papers and make sure they're not plagiarizing each other. And he realized, hey, I have access to this, and I can read these papers for free, and no one knows I'm doing it, and I get them a couple of weeks before they go to print.
Whoa.
Because they're being checked. And so he also submitted a few fake ones. They never got published because he was a kid and was terrible at spelling. So they all got removed.
I was about to say, was your dad like printing like fake news? Hella.
Nah,
I see.
he submitted a few
Aliens
fake
landed
ones
in the
and they all-
backyard.
They all got caught.
That's so crazy. What did your dad end up doing? Where does he work now?
He works for a computer storage company. I won't say
Okay.
the exact one, but they handle computer storage, data storage, all that stuff. So he's still in those general fields, but much less malicious these days.
Making diabolical machines in his basement. Dude,
Yeah,
that's so crazy.
So back in the 80s,
What?
he had to write a science paper for his science class, in high school. And he couldn't figure out what to write, so he was just reading the headlines, that wouldn't come out for another 2 weeks, as you do. And he saw some article about how they had discovered quarks, and he was like, "Oh, a new subatomic particle." So he steals like half of the article for his essay
No way. Oh yeah, and there's no copyright because we don't even know.
because it hasn't been published yet.
That's so crazy.
So he turns in his essay to his teacher. The teacher's like, "What? This is a really well written article, but
Dude,
it's about gibberish.
the
Quarks
kid-
don't exist."
The kid that can build a machine that recognizes robotic voices, copy
Robotic
pasting his
voices are
papers
really
for
easy to
scientific.
find, honestly.
Bro, how would you like? I could not use this computer to recognize voices. Period, bro.
recognize
Like no one
human
can.
voices.
Yeah, I can.
Yeah, it's like it would just call random numbers, and if the thing on the other end made a handshake protocol, which was like it was a specific series of metallic screeches that would signal the computers that, hey, there's another computer here.
Oh,
It's like
so
how-
there was an actual like it was already the phone was trying to communicate to a computer
'cause
already.
They
Okay.
the banks and the journalists, they knew no one who doesn't know this
Yeah.
number will call it, and no one who doesn't know what
Yeah,
this number
it's so
means
crazy.
will call it. So we'll just set it to handshake anyone who calls it, so that their computer can connect to it.
That's so crazy.
And so he set up his computer to handshake, write down the number, and then hang up.
Dude.
Yeah, so he wrote an article on a subatomic particle that, to the knowledge of everyone, did not exist, but it was a really high quality article.
Wow.
And
In the
his
80s
science
too,
teacher
so
his science teacher was like, "This is gibberish. It's really well written, so I'll give you like a D." But, quarks aren't real. So what are you talking about? And he's like, "Oh, you just wait." And a couple weeks later, the article
You just wait.
a couple weeks later, the article gets printed.
I'll show you. So you wanna...
Yeah, so a couple weeks later, the article gets printed. He goes to the news store or wherever they sell articles. I don't know how newspapers work. I'm a Gen X or Gen Z or whatever.
Dude, that teacher must have thought he was Einstein, bro. That's insane.
Yeah, so he buys the newspaper with the article, brings it to his science teacher, and is like, "Hey, look, I was right. Quarks are real." And his science teacher's like, "Wait a second, you copied this. This is exactly the same as your article."
You should have found another article. You
No.
should have found like.
And then he pointed out, "No, I turned this article into you 2 weeks ago. They published today. They're copying me."
That's.
I'm pretty sure he was given a spite B plus, just to get him out of his hair.
That's crazy. They should have given him an A. I don't understand why they wouldn't give him an A for that.
Yeah, I don't remember the exact number, but he was given a good grade out of spite, just to keep him away. Yeah, computers were weird back then because they just did everything by sound, They just had a bunch of computers that would open a call on a normal telephone and then just scream at each other in a way that no human could ever understand.
Like the computer dog whistle.
Yeah, exactly. And they just, as long as they're screaming at the right frequency and as long as the telephone line isn't getting screwed with, they can talk. That's how they used to do internet back in the old days. Back before all these cellular networks and fiber optic cables.
Times are wild, man. Dude, I wonder when did they put in all the fiber optic cables?
I don't know. They've been doing it for a couple years.
I recently found out that they're just like running under the ocean. I didn't know that before.
Oh yeah, they did like metal cables back in like the 1800s, but those sucked.
Through the ocean?
Yeah.
On the floor?
It would take like an hour for the current to travel, I'm pretty sure.
What? I didn't know that.
It was still way faster than sending a boat, but
Yeah.
And then occasionally like a shark would just murder it, or like an anchor would cut it in half, and then they'd be like, oh, well, guess we gotta pull the whole thing up again and fix it. And so they never stayed up for very long. But now the new ones are like buried under the seafloor.
Yeah.
So that they don't get destroyed as easily.
Crazy. So, do you got any last wisdom for our listeners? Any advice? Anyone? Anything for anyone in college out there? Anyone out there at all?
Actually study, I learned that because I've definitely cut it pretty close with some finals. Actually study several days in advance. Don't study all of it the night before. That's not real. It will help you, but it will not help you as much as studying 2 nights before.
My biggest thing about like studying before is I don't think it's really founded, but I always feel like I'm not gonna have time for the things I want to do. Mm-hmm. I'm like, oh, if I study before, like I'll just be like, I'll feel like I need to study again, and like so I might as well spend my time on like projects that I actually want to spend my time on, and I'll just like allot like as little as possible to school, just enough to like get through the class, but like. I have other things like I'm interested in, and I feel like I'm sure that happens to a lot of people. So when you study early, do you feel like you kind of like give up that free time, or do you still feel like you have a lot of free time? Because I think I'm kind of tripping about that. I don't think that's...
Yeah, I think you are tripping.
Yeah.
Like if you study early, then you don't have to study later, so you can chill out closer to the exam. And you get that nice mix of the happiness of hanging out and the dread of the upcoming exam. It's intoxicating.
Oh.
But yeah, I do recommend, study earlier instead of later, because if you mess up studying earlier, you can try again. If you mess up studying later, studying after the exam is not going to help you.
You get to try at the exam, man.
Yeah.
That lets you know.
Wing it on the exam.
I like that. I like that you may like the mix of happiness and terror of the exam. I like the elation of going to the exam and having no idea what's happening.
If you don't know what you're doing, you don't know how bad you're doing.
I like to go wingsuit diving at night, Nico. Let's get in this.
Yeah. It's always like if you start an exam and you finish it first, that's terrifying. But if you finish it like halfway through, then you're golden. Then you know you did at least okay. If you finish it first, you're either the best in the class or you failed. If you finish it halfway through, you're mediocre. But mediocre is good enough for most people. That's why it's called mediocre. It's the middle.
Yeah, those people that walk up like right away are terrifying.
They scare me.
They're terrifying either way.
Even when I am one of them, they scare me. Yeah, it's spooky.
All right, Nico, it was fantastic talking to you. I hope everyone out there enjoyed this episode, and you all have a great day.
Have a good day.